As structures to increase the functionality of supramolecular structures grows, this method of incorporating 1,2-dithiolane groups with self-assembling peptides can help answer key questions about reactivity on supramolecular surfaces.
The main advantage of this technique is that the coupling and deprotection of the 1,2-dithiolane precursor molecule occurs on resin with only a single purification step of the final modified peptide.
As the time it takes the assemblies to mature into their final supramolecular structures varies, visual demonstration of the characterization methods and results for the supramolecular assemblies is critical.
To synthesize the dithiolane precursor, first dissolve 1 gram of 3-bromo-2-bromomethylpropionic acid in approximately 4 milliliters of 1 molar sodium hydroxide in a 50 milliliter round-bottom reaction flask at 55 degrees Celsius with stirring. When all of the reagent has been suspended in solution, seal the reaction flask with a septa and place the flask under nitrogen atmosphere. Next, add 1.49 grams of potassium thioacetate and 3 milliliters of 2 molar sulfuric acid to 4 milliliters of deionized water to create thioacetic acid in situ. Aspirate the thioacetic acid solution into a plastic disposable 10 milliliter syringe and equip the syringe with an 18-gauge needle. Then pierce the septa with the needle to add the mixture dropwise to the reaction flask and continue the reaction overnight at 55 degrees Celsius. The next morning, monitor the reaction by thin layer chromatography on silica gel 60 F254 plates using a mixture of methanol and dichloromethane and visualizing